So now, take a look here. We'll now officially start with the Node.js part. You guys have been already using it to some extent, right? Using Node in your command line to run a JavaScript file, or at least I was showing you guys how you can do that in your own computer. Okay. So this is like the general outline. We'll switch it a little bit based on how the course is going. We're right now in week 0 actually. Like the preparation, you will see it in the GitHub repository as well. Right? That begs the question like, what is it? What is Node.js? So this is the definition on their website, which is like Node.js is a platform built on Chrome's JavaScript runtime for easily building fast and scalable network applications. Right? Pay attention to some of the network applications. Node.js uses an event-driven non-blocking I/O model that makes it lightweight and efficient. Non-blocking I/O model. Do you guys know what's I/O? Input output. Have you done what's non-blocking? Just like this is not really very technical. Just think in terms of like what do you mean non-blocking? What is blocking? Stopping. Right? What means non-blocking? Yeah. So non-blocking refers here to doing, like if you're trying to do one thing, it will not freeze your system. You can do another things at the same time. So non-blocking, now do you know, like have you used non-blocking concepts already? You're doing one thing, but you don't want to wait for it to finish. You can start doing another thing. Promises, callbacks. Right. JavaScript and particularly Node.js really made it quite more popular to use these kind of like techniques for non-blocking asynchronous execution, right? As we mentioned briefly, like in other programming languages, what you do is like you open a thread and you manage it manually. So because that's like the underlying method of what the languages are doing. Like one chain of command is called a thread. So you do thread management manually in most of the programming languages. Right? In JavaScript, it was abstracted through callbacks and promises now. Right? So non-blocking I/O model that makes it lightweight and efficient, perfect for data-intensive real-time apps that run across distributed devices. Okay. So far, like when particularly like I've been teaching, like I don't tell you guys at all, like, why you're doing what you're doing, kind of. It's very much like, do that. And it's more like a critique of like the things that you do, try to make it do better. But now, particularly with Node.js, and definitely more with React, you have to also understand why you're doing these particular things and not something else in another way. Because once you go out and like in the industry, somebody is going to ask you like, why Node.js for this project? Why JavaScript for this project? Why this framework for this project? Right? You need to know why you're using what you're using. Why Slack companies are using Angular, React, or Node.js, or Python in some other case, or C# for game development. There's like, there's a reason for something. And if you're aware of it, then you'll probably make the right choices in your own projects. And second of all, people are going to trust you more because at least you know what you're talking about, right? So in the case of JavaScript, the words which are important is that lightweight, efficient, data-intensive, real-time, distributed devices. Okay, all of these are actually very relevant in the case of Node.js. Let's start. Lightweight and efficient means that in order to install Node.js, it's quite easy. You don't really need a lot of other dependencies on your system in order to run Node.js. Mostly what you need is to have C++ installed. And then you just get the Node environment, and usually that's it. Right? and it's self-contained. Once you install Node.js, you don't need to install some other parts of system libraries. You'll understand it once you start working with Python at some point, then you'll see the difference. Yeah. Data intensive and real time is completely linked to the non-blocking and asynchronous part of it. Because once you're getting a lot of data into your application and you want to process things continuously, then you need to have a way that you can deal with latency, which is like, what if the data stops coming in? What if there's more data coming in than you can process in real time, right? These cases, if you have like only a program like in Python, like it really by default, it prefers to keep only one thread, right? Or, yeah, you would kind of like suffer in that environment because like your program is going to reject data coming in by default until it has finished processing the last packet of data. And for some things, it's fine. For a lot of things which happen nowadays, it's not great at all. Also, real time, because the moment you get the message, you need to at least store it or like put it in one state, even if it's not completely processed, so that you can keep accepting more data and also keep other things passing. Like for example, if there's like the usual case where things become complicated is that when you have jobs, which is to say that there's one microservice on your system which is like consuming the data. Like think of it as like a Slack like application, chat application thing. So you have like one microservice which is like a user said this, a user said this, a user said this, like messages from a user. That's been coming. You have to take this and put it into the database and then throw it into the users. But then there's like jobs, which is like if the user tries to upload a file, check what file, check what is inside, see if the other user is online, send them a notification. There's like a lot of like small logic which needs to run, and think like if like one user anywhere in the world is trying to upload a 1 GB file, which they could, they pay enough money, Slack lets you do that, right? And if let's say it was running on one computer, which it won't, but still, if during that upload nobody else could do anything, even if it took like 5 seconds, that means that no user is getting any notifications, any chat. They can't even up and press enter on their keyboard for 5 seconds. Like, I don't know, hundreds of users, thousands of users, and that's like completely unacceptable. Like we're talking about apps which are building, they're using milliseconds, 200-300 milliseconds to get responses. 5 seconds, that's not going to fly. So okay, even though this user is uploading data here, doesn't matter. The other guys can still send messages and I will still deliver messages for the other services. That becomes important. But also distributed systems, which is to say, well, if you want to run a big service, you cannot get a computer big enough to just do everything on that machine. So you need to create like several instances, small computers which are communicating with each other in order to fulfill the overall service. Right? Because there's things like, one computer might get its disk full, one computer might die, so they have to share state and also message each other. And Node.js makes it like amazingly easy to do that. I've tried doing that in a lot of different programming environments, and like before Node, it was usually much more annoying to do that. You guys will see some of its side effects in the database class, where the way you would be interacting with the databases would be like remarkably easy, especially compared to what was state of the art before that, which is more, if some of you guys might have done it in Java, you will see the contrast between the two approaches. All right? Also, this is like the definition on their website, and they haven't really changed it for a number of years. But what Node.js is also known for is that it's lightweight enough that it can run on very small devices as well now. So you have Node.js running inside Android, on Raspberry Pis, etc., etc. So the distributed part of it is really taking off. You have like the full environment available to you, which is really fantastic. Also, JavaScript together has just like exploded in terms of like the where you can use it in the different number of places. So, starting with like things like Backbone.js, which none of you probably have used and won't use it, which was the first MVC framework. Then moving into things like Angular, which came along the way, to React. Angular, React are like such big frameworks that they let you build applications all across, like all kinds of touch points. With React, you can use React Native to develop mobile applications now, and it's like really quite popular. Similar with Angular, you have Ionic, which is, again, you can build apps, which is again popular. And although those are, mostly JavaScript frameworks, they wouldn't have been possible without Node.js, because most of the tooling where they compile the apps, etc., the tools which they use for like linking the libraries, converting it into system code for Android and iOS, all that is written in Node.
Sorry, bit on Chrome.
Chrome, yeah. Yeah, so yeah, because Node doesn't work with that because Node is a backend framework. So Node is literally like Node is basically your Chrome without the user interface. It's like pretty much that, and like without the settings and blah blah, like nothing to do with rendering, everything to do with running JavaScript. And that's why, like, the same way you like console log in, it's basically like when you press console in your browser, right? That's basically Node as far as most things are concerned. Hmm? What is?
In order to say console log, we can say alert.
Alert. Okay, yeah. No, there's no alert because alert needs system UI. Node doesn't have like UI. It's just the console part of Chrome in a way. You'll see a lot of similarities in that manner. Leave anything? Yep. So these are, I think I've explained much of this. Node.js, you write it in JavaScript. It's basically like the console, right, in your browser. It's lightweight, it's efficient. You'll see very soon. Perfect for data intensive and real time, what I just explained with like the real case scenarios. There's a large ecosystem. There's more libraries available for Node.js in JavaScript than any other programming language. Even though JavaScript is not the oldest programming language, even though Node is not that old as an ecosystem, but the number of libraries is the largest, because you have libraries for doing like really, really small things, and you have libraries which are like basically gigantic frameworks. You have the whole spectrum, and the variety is larger than any other programming language, easily. Isomorphic application, which is to say that you write programming logic for the front end. If you so want, you could move it to the back end. The language is the same. You could actually put a lot of like shift a lot of the logic from front end to back end if you so desire, because the language is the same. And this is unique because the browser only runs JavaScript. That means that you cannot have an isomorphic application in any other language. It will convert itself to JavaScript at some point. Question time. Is Node.js only good for web applications, web stuff? What is it?
About consuming backend.
Yeah, but backend web applications or something else as well?
Also, I think you mentioned apps.
Sorry, what?
As you said, apps. You mentioned apps and all that small.
But web apps or other kinds of apps as well? That's the question.
I think you can use for other apps.
What sort of? What would you use it for? Yeah, no, but this is like that's still mostly like a web app in a way. But yeah, that's one sure variety.
No, much about programming language, but if you have kind of, since it's server language, if you have any system based on server, I don't, maybe you can use it.
Yeah, this can run on like most architectures. That's not a problem. But what kind of app would you use it for example?
iOS and you said dealing with the Python, so most of apps work with Python.
No, like Python is a separate programming language, so it's not related.
That need to fetch data immediately for the user to
Yeah.
offsend. Offsend that.
Yeah. So basically, like even for like it's actually being used in all kinds of services. Sometimes a lot to do with because I work in that area for like let's say mapping and geodata. It's being used there a lot because it can handle a lot of data very efficiently, and that might not have any web interface. It might be completely like a command line app. Node.js is still a good framework for doing that because of the speed and because it's also like very easy to debug compared to some other given the use case.
What about distribution?
Yep, distributed like most of like scrapers. Scrapers are not web apps. They go on the web and like crawl and like a lot of scrapers are written in JavaScript. Most are probably still written in Python, but a lot of them are written in JavaScript. There's all kinds of services being written in it to fetch data from other servers as well. So like in my company, we write a lot of services to gather a lot of like weather and geological data. It's
You don't know what services are. Okay, so someone who does services.
what do you mean when I say service?
Service, all these app service, all this website, this service, the current protection, current status of events.
Now, in this case, like service is something more specific. It's like no, it's like I have designed a program which is persistently accomplishing some function and reporting the status of it. That's like, in very simple terms, that's what I call a service. You have like microservices, which is like they do only just like one thing. When asked, they do one thing and then they disappear. But then you have like bigger services which run on big clusters of computers the whole month, the whole year, whatever, and they keep on grabbing data, changing into something else, matching things, doing maintenance on your infrastructure, that kind of sort as well. Node.js is making its way into a lot of these sort of services, again, because of being lightweight and easy to write in distributed. You want a service to run on many computers, Node.js is a pretty easy choice there. So this is not. We put this example here just to kind of emphasize the non-blocking aspect of code, okay? So this is in Python, this is in JavaScript. You can see that you can read both of them almost the same way, but it's like the way the program is being written. It's like it's step 1, step 2, step 3, step 4, step 5. It's like step 1, step 2, step I don't know when will happen. This is great because step one, step two happens immediately. Here, this will not happen until the final file is written. It doesn't, which is not good. Like it might not have anything to do with the file being written. Why should it wait for the file being written? But you have no alternative. Here, you have alternative. If you want to know after the file is written, write it here. Otherwise, just write it here and it will happen as the file is being written. Yep. So you guys have installed Node. I will, after this class, write instruction just to let you guys verify that you have the right node, and I will check this since we took the last class. Node 9 was released, and I will check if we really need to use that, if there's any nice feature, and based on that, I might tell you to upgrade it, but it would be in the same homework post. Right? All right. Which language is Node written in? Okay. Who all thinks it's written in JavaScript? Raise your hands if you think it's written.
Node.js, I think it stands for JavaScript. Node.js. Node.js.
Yeah. Which? Okay. Quick, you don't know it anyway. Just guess. Yeah. Okay. You also think JavaScript? JavaScript. Okay. You guys are right. It's C++.
Yeah.
Node.js is a JavaScript framework, but it's not written in JavaScript itself. It's written in C++ actually. Which is like, well, the thing is, the simple reason is like, well, Google wrote V8, they decided to write it in C++. But no, the more reason why they took this reason is because C++ is brutally efficient, and they were writing the fastest browser, Chrome. So they wanted to write it in a language which is extremely performant, C++. C++ is more performant than JavaScript. There's no doubts about it. Right? That was the main. But the second reason, which is absolutely great, is that now it can run on more systems, because like how many computers have JavaScript installed? I'm not saying the browser installed. Browser they have installed, but they don't have JavaScript installed on them. C++, most computers have C++ installed one way or the other. Right? So Node.js is written in C++. Python also is written in C++ and C. And there's a lot of other programming languages. I'm not an expert in this area actually. Most are in some way written in C or C++. Okay, so just know that, because really Python, I really don't think so. Did you look it up now? Or? Okay. For sure. Yeah.
But the main reason programming languages are written in C or C++, C is directly working on,
Yeah.
exactly.
And C++ is basically C, but some nice sugar on top. So that's basically, let's say at some point more than 30 years ago, everyone was quite happy with C and C++, the way they were working, and they, like most of the architectures started getting designed around that. That's a very simple C. C++ wasn't even there. Yeah. It has a completely separate domain, unfortunately. But yeah. This is like probably the last thing for the day. NPM, right? All of you guys have it, but you're not really using it because you didn't really need it yet. NPM is the package manager. It's basically literally Node package manager, NPM. Right? So it's the package manager for Node.js, and it happens to be the world's largest package manager means that like Node has more packages written for it than any other programming languages, which is kind of fantastic given that, well, like Node came out, less than 10 years ago, I think. And well, think of like some programming languages which are here for nearly 40 years and which are still going on. Node still has more packages because it's just used at so many different places. There's so many people writing packages for it, and it's also so easy to write software and distribute it because npm is really, really easy to. You can make your own library by the end of this course. It's that easy, and like something useful, you would be able to publish it. People would be able to download it publicly. Works quite well. Uh, this is where we'll begin the next class, which is Node modules, which is like package which you have downloaded onto your computer and you want to use it in your program. That's called a module. So you say that at the beginning of a file, you say, okay, you want to use this module as this kind of function or this kind of object, and then then it's loaded as something named, and then you just use it as a object basically from that point, or as a class, which is why it's quite important to do object-oriented programming now. Right? The main concept behind package management in general is to keep things modular and reusable. You don't keep things on your computer which you never use. If there's one thing which does one thing very well, let everyone use it, etc. Next class, we'll continue on classes. We'll start working with Node on our computer in the Node terminal, then start to work on files, run them with Node. Right. Promises which we've already done. In the last class, we hadn't done promise till this point, which was a serious topic, as you can imagine now. We'll install a couple of packages and see how to use that. And then we'll create a boilerplate which we'll use throughout the rest of the module. A boilerplate is basically like a template which you use to begin working, which has some things installed which you would most likely start with all the time. Yeah. So, for example, the boilerplate which you guys use right now is like you create a folder, you create one file called index.html, one file called index.js, you go into the index.html, do all the basic tags, and then say script, and then load index.js, and that's your boilerplate right now. But now we're getting into backend. There's like all kinds of more possibilities now, reading and writing from the file. We'll do it next time. Or file system, we'll do it next time, and other kind of stuff. So consequently, your boilerplate can extend a lot. You'll also see like how you can speed up development in your machine. Things like you write on your editor, you press save, the browser refreshes automatically. You don't have to do anything, which you can probably understand could save some amount of time. The flip side of all this is that now if you don't follow, the risk with every class will keep on increasing because in Node module it would be much more practice based. I would almost not introduce any new concept. Like no promises. We'll do a little bit syntax changes, but nothing like we would just be writing and I would just be showing you how this could be done, how that could be done. But like that means that everything is practice based. That means that we'll actually be writing much more code than we were writing in JavaScript 3 because then there was a lot of blah blah blah, So if you don't write code yourself, even if you miss the lecture, go look into the homework, look into the classwork folder, actually comment it out, run things line by line, and see which part you understand, which part you don't, and do the homework, because again, for the sake of continuity, we will keep on using the homework to add new concept on top of each other. By the time we come to React, your homework would literally need you to write probably more than 200 lines of code for each homework every week. So make a bridge in your head and figure out what you need to do now. Because the React module would need a complicated application to run on it. Right? So there's no way getting around it. In this module, you will need to write more code than basically any of you are writing right now. Right? So understand this pretty well. All right. What will be arriving at the end of this module is basically in the last homework, and also what you guys did today was we were consuming an API and processing the data into a class. Right? Now we'll be making an API. We'll be serving this thing and then also create basically the same code that we had today. We'll still be using it to consume the things from our own API. So now you'll have a completely self-contained system. Then in the React module, you would again go back into frontend and then say, okay, now I have sophisticated API which I can change myself. Now I want to create an application which looks nice. So you'll go use the skills from HTML and CSS class and actually start rendering that into like a web page which looks like something and not like black and white, which we did in the last module. And in the database, you'll be going like, okay, all that is nice, but I only have 10 objects, which is not great. Now we connect it to a database. Now we can add as many objects as possible and read as much as possible. Yep. That's the alarm I imagine. Yeah. So, what? Your applications? Yeah. Also, what we'll probably even do in the next class is that when I run a Node server, you will be able to connect with your computers, because in local network it's kind of open, so you just need my IP import and you can just access it. So we'll mostly be running things in that way. That will just let you know that, okay, it's basically that you're already there. You can publish things you can create your own websites, dynamic websites, and publish things on the internet just that way. And the actual setting it with domain, having a database run consistently, that will only happen during the project module. So that will be after database, because that database is the thing which actually needs the most upkeep in kind of like keeping it running with the application constantly on top of it. So that will come as the last step. But you'll already see the whole stack in terms of networking in next class.
What about the instance whereby the user has to retrieve data that has to be stored? I'm thinking of the kind of project I'm thinking about. It's like
we'll do it in class 3. You will start receiving data and saving it in the backend.
I'm thinking of something like build-based or DBA.
Yeah.
User can upload stuff and
yeah, or like even like whatever Facebook, Twitter, or Slack, where you can write a post or a comment or something. Yeah, we'll have all that already in class 3, definitely. Right. So for today's homework, they would be an extension of what you did in class, mostly. I will put a few like kind of tricky scenarios for you to make it run. And if you didn't do the holiday part, I would really recommend to do that and kind of like iron out some of the conceptual difficulties.
Actually, my question James, just today I see that even the last before the holiday, you show us how to work. But I didn't find it anywhere on Node.js. I explore all the games and last night. We have to finish the all 3 games or 2 games.
So the first 2 games are just for playing and solving challenges. The third one is actually you follow along and you make it into a yeah, and then you start changing things on top of it. Yeah.
So it's just changing. You don't need to do anything right from the scratch. Or
I've already
Pretty much, yeah.
gave the answer. Try not to see them. Try to do it your own work. Like struggle a lot, then you can. But the last one for the robot, it's not done. You can maybe work on it and.
I was working in that like for level. Last night and started the online so that I don't see this.
No, this will be weeks ago. But I will update it because it's going to be slightly different.
I see that it's not implemented yet. There is a HTML error, as you said. You should have, for the wall, you should have, if you're only the check edges like that, you should have check bricks and check pedal methods, then it will work. That's the only reason.
For the homework, the list of priorities this week's homework. You first do this week's homework because next class you need this week's homework to continue, right? If you manage to do this, then go for the 2 games, which you have to play, kind of revise it, and then the breakout game if you still have the time, because that is like you learn a lot with that. And the last week's big homework, you don't need to do it because today's homework is going to be based on that. Yeah. The homework? Yeah, it will be today. Sure.
Any question? Something?